Hello, everyone, and welcome to our webinar, Llama 2 versus Mistral for fully private Gen AI apps. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you're currently in a listen-only mode. You can submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a SingleStore webinar, heads up that we present regular webinars demoing data and AI use cases and new technologies. So on Monday, we are going to be presenting a new webinar. If you click to the next slide, you'll see the title of that is Real-Time AI with Kafka and Streaming Data Analytics. If you're interested in leveraging streaming data from Kafka for real-time AI applications, come check out the demo we'll be doing on Monday. It uses LangChain and OpenAI to be able to ask questions to an ad tech application. So things like which campaigns are performing the best? What are my top 5 advertisers? Are certain ads performing better based on certain gender or income characteristics? So if any of that sounds interesting to you, you can RSVP right now. There's a bit.ly on the screen. I'll put that in the chat in a few minutes as well. You can also take a photo or a screenshot of that QR code, and I hope to see you on Monday. And then I'm also excited to announce that on January 24th, we're going to be presenting another big event. If you click to the next slide, you'll see the title of that is Meet SingleStore Pro Max Powerhouse Edition. If you've attended our previous webinars, you'll already know that SingleStore is positioned to be the best database for real-time AI at scale. The event on January 24th will unveil all the new features that our engineers have been hard at work on for several months. We've got 1,000x faster vector search using approximate nearest neighbors. Got new on-demand compute service for CPUs and GPUs. We've got a new job scheduler for continuous vectorization of data streams. And we even have a new free forever tier. You probably know we already have a free trial, but I hope you'll come check out this new free shared tier, which will be available to users indefinitely. So if any of that sounds interesting to you, I encourage you to register right now. There's a bit.ly link on your screen. I'll put it in the chat in a minute. Also a QR code. We have an on-site registration. The seats are limited and running out quickly. I'm not even sure if we still have some, but there is an on-site option for anyone that lives in Silicon Valley. We also have a virtual registration for everyone else around the world. So I hope to see you there on January 24th. Back to today's topic. We would love for anyone to try out the technology that we're going to be presenting today. We have a demo that you're going to be able to follow along. And if you try out this technology today during this session, then you'll be entered for a chance to win new branded AirPods Pros. These are the latest, newest version of the Pros that Apple has released. All you need to do is click that link on your screen, bit.ly Llama versus Mistral raffle. I'll put that in the chat in a minute. You can take a photo or screenshot of that QR code as well. And all you need to do is log into SingleStore. As I mentioned, we've got a free trial. If you're a new user, no need to input a credit card or anything like that, completely free trial. Or your existing account, if you're already a customer or an ongoing trial, you can just log into that existing account. And we will check the folks who log into this link today, and we will announce the winner by the end of today's session. So enough preamble. Let me introduce our speaker for today. Alexander Peng is a growth engineer at SingleStore. His formal training was from Stanford Computer Science program. He has expertise in big data, machine learning, and AI, and he is quickly becoming a regular speaker at our weekly webinars on data and AI. Welcome, Alex. The floor is yours.
Cool. Thanks, Matt, for the intro. So I just wanted to get us started by just kind of laying a foundation so we all kind of have a shared understanding of what the topic we're going to be getting into today. Some of this might be, stuff that you already know, but this is just to cover all our bases. So let's first think a little bit about the emerging architecture that we're seeing for LLM applications. And specifically, today we're interested in thinking about commercial and more specifically open source LLMs. As many of you are probably interested in open source LLMs, given that this webinar is talking about Llama 2 and Mistral models. So let's take a look at Llama 2 first. Llama 2 kind of broke out onto the open source LLM scene. We saw the first Llama model come out from Meta's Facebook AI Research Lab. And then we saw many fine tunes of this first Llama model. We saw them named after, different animals in the kind of llama family, vicuna, alpaca, so on. And we saw, with these really early open source models, that there was still a lot of juice left to be squeezed out of the kind of base model weights, right? And then we saw Meta kind of raise the bar again with Llama 2 with improved performance at the same kind of weight classes. And just like we saw before with Llama 1, with fine tunes coming out for Llama 1, we saw fine tunes come out for Llama 2. And Mistral has actually come out with a fine tune, which has kind of blown everyone away. They've come out with a 7 billion parameter model, which matches and sometimes even beats ChatGPT 3.5, which is the kind of gold standard for like fast LLMs that are cheap to use. And in GPT 3.5's case, it's the free model that you get to use when you go to the ChatGPT website. And even more recently, I believe in the last few weeks, the Mistral mixture of experts model came out. And we'll talk more about all these terms in the next few minutes, but this continued to improve upon Llama 2's initial performance, getting the best of both worlds, getting almost GPT-4 level quality in their responses while getting like GPT 3.5 level performance. And we'll talk a bit about how that's possible. So what's the deal with parameter count anyway? You may have noticed, I was talking a bit earlier about, Llama 2 kind of releasing models in the same weight classes as in Llama 1. Those kind of parameter counts specifically are, 7 billion, 13 billion, 35 billion, 70 billion, and so on, right? And the kind of upshot of this all is that if you have less parameters, it'll be cheaper. The model will be cheaper to run and faster to run. But you do trade off on, factuality performance, reasoning performance, generalization performance to be able to work across, a wide range of domains, like even kind of more obscure domains. And the reason for that is basically you can just think of the parameters. This is not a one-to-one mapping. I'm trying to keep this at a high level so that everyone can understand. You can just think of the number of parameters as the amount of memory that the model has to work with when it's learning, right? It's trying to fit all these different concepts into its parameter space, and the less parameters it has, the less it's able to remember, but also the less that it has to search over when it's actually generating text for you. Kind of getting into the nitty-gritty here. If you have, for example, a 70 billion parameter model like the Llama 2 model, like the highest end Llama 2 model, you're going to need something like 64 gigabytes of GPU memory. And that's definitely not consumer grade. You're not running that on, definitely not running that on your MacBook, definitely not running that on even the like $1,000 gaming PC that you built. You're going to need some serious hardware, like some of NVIDIA's specialized GPUs, multiple of them actually, just to even load the model weights and be able to generate text. However, we've seen with some of these near Mistral models, they've managed to get the parameter count low enough while keeping the quality at a really good level, beating GPT 3.5 even. They've managed to get it down enough that you can fit it within 12 to 16 gigabytes of memory, which is actually pretty feasible for most consumer hardware, even laptops. As you'll see in the demo that I'm about to run, we're able to run it on a free Colab instance. So, if you don't even have a as long as you have a laptop with web browsing capability, you could be running these models, right? Let's also talk a little bit more about how this even all came about. This mixture of experts idea. This is a really new LLM architecture which is emerging, which has emerged. I believe the most prominent model to use this mixture of experts architecture is GPT-4. So that's the paid OpenAI offering. That was actually leaked, a few months ago, that GPT-4 was the kind of bleeding edge LLM architecture, and then everybody started to try to replicate it. Mistral is kind of the first open source success with mixture of experts taking the Llama 2 architecture and breaking out the parameters into so-called expert models or submodels of the larger model. And then what happens is when you actually run inference and you try to generate text from the model, you're pulling knowledge from about 50 billion total parameters, but the model chooses two kind of submodels to actually run the inference on at text generation time. And the total number of those submodels, the whole total parameter count of those submodels is something like 13 billion. And as we mentioned before, less parameters, better for performance, right? But in this case, we almost seem to get the best of both worlds where we're getting performance and quality. So now that we have the LLM piece covered, we've kind of gotten a deep dive into the newest LLM architectures, into some of the newest open source LLMs that are coming out. Let's talk a bit more about retrieval augmented generation, which is probably what most of you are interested in. LLMs give us the ability to, predict the next chunk of text based on a previous chunk of text, whether that's a user typed prompt or proprietary private company data that you actually would like to perform some reasoning over. Retrieval augmented generation is the way by which we actually get this prepended chunk of text. How do we know what company documents are most relevant to this query? How do we know the kind of ordering in which to place these documents? These are all questions that retrieval augmented generation answers. So just skipping over a few of these. This is kind of a very high level architecture of how we actually implement this, where you can kind of look at something like ChatGPT as an example. You have the UI, and then you have API endpoints hooking up the UI to a backend which serves the LLM, and also can in some cases serve your retrieved text. In our case, we're coming from SingleStore. Call us biased, but we think SingleStore is the best way to store this text, this company data that you would like to actually reason over with LLMs. Let's think a little bit more about that. SingleStore exists in what we call the contextual data layer, right? This is a data layer where you can store both structured and unstructured data, right? We obviously have support for standard SQL tables. You can perform standard SQL queries over every single SingleStore database, right? But when you're working with LLMs, you're also working with something called vectors, right? You're working with something called vectors. And just at a very high level, vectors are lists of numbers that store information about your private company data or your kind of personal text that a database stores, and then that you can search again over when you're querying an LLM to find the most relevant chunks of information. Don't worry if you can't hold all of these details in your mind, mixture of experts, vectors. database, inference. We'll get all into the nitty-gritty in the demo. But just before we do that, a little bit more about SingleStore. SingleStore is a database to transact, analyze, and contextualize in real time. These are just some very high-level testimonial stats from some of our real customers, and just a bit more about the kind of underlying architecture of SingleStore. And a really exciting new feature that's come out of SingleStore very recently is the ability to run web-based notebooks, Jupyter notebooks, which can actually connect directly to your database in SingleStore. So you'll see in our notebook demo, we do have to include, sort of authentication string, containing the username and password and the endpoint URL and the database name. But if you go to SingleStore Spaces, you can actually create an AI application that talks directly to your database, and it all kind of exists within the SingleStore space. Nothing leaves it. And you also get all your compute there too. Okay, this is just a little bit more about some of the AI capabilities of SingleStore. I covered it, so I think we can just skip over this. Okay. Awesome. Let's get into the demo. All right. So not to worry, all of this code is going to be available after the webinar in the form of it's going to be in a GitHub repo. But just quickly go over what we're going to be doing in this demo. So we're going to be looking at Llama 2 and Mistral. The ways that the way that we're integrating Llama 2 and Mistral with SingleStore is actually using a really cool library called LangChain. Many of you who have kind of dabbled or worked in the LLM space so far are probably very familiar with LangChain. SingleStore has a first-class integration with LangChain, and so that means you can create new tables, you can modify tables, you can delete rows from tables, you can kind of upload all your documents and chunks after embedding to SingleStore, all within LangChain. It's actually really convenient, and you'll see how that's all done. So let's just get into the code here. These are just some just package installations that we need to do, obviously LangChain and SingleStore. And we're actually also going to be using this package called Llama CPP Python, which is a wrapper around a really cool GitHub repo called Llama CPP, which allows you to run these open source LLMs directly on your own computer. So I would definitely go check that project out if you're interested in working with Llama CPP outside of Python, maybe in like TypeScript or something. LangChain also has a really cool integration over there. We're also going to be using sentence transformers, and that's a embedding library which allows us to use sentence transformers embedding models, which are locally runnable embedding models, because this is a fully private GenAI app. We want to keep everything on our own computer. We don't want any data leaving our computer. And so everything that we're doing is runnable on standard consumer hardware, though obviously you can scale it up if you would like. You can scale up the parameter counts on the LLMs. You can find larger embedding models for better performance. But we're starting at the consumer level here. We'll also download the GGUF files. So the GGUF files for Llama 2 and for the Mistral models. And these are essentially, you can think of them as just compacted model weights for a specific model that you can then run with, Llama CPP. So this is a Llama 2 model. This is the Mistral model. We're going to be running the 7 billion parameter model. If you are interested in running the mixture of experts model, That's also basically just a plug and play from the Mistral 7 billion parameter model. You just find the GGUF file link on Hugging Face and just plug it in here and change the file name in the argument. So then we're just going to do some imports to get all the necessary functions that we're going to be using from LangChain. And for actually loading in the LLM, we're going to be using the Llama CPP wrapper and LangChain. So these arguments are actually pretty important. I'd make sure to try to hew to them as closely as possible. The important arguments to point out here, N GPU layers is going to be dependent on the performance and more specifically the video RAM capacity, GPU RAM capacity. I'm not a robot. The GPU RAM capacity of your GPU. So, 40 is kind of the general baseline, though you can basically have it up as high as you want if you would like it to use more of your GPU. Though do be aware of the fact that if you set the number too high, and I ran into this problem when I was testing, if you set the number too high for your GPU memory, you will crash the program. Another argument to point out here, the context window and NCTX. The mixture of experts model actually has up to 32,000 context length, which I believe is at parity with the ChatGPT 3.5 model. 7 billion, I believe, has a context window of 8,000 tokens. So I just have it here set to 4,000, though if you want, to input more text, you'll want to change this argument. And then also max tokens is going to control how much you actually generate. So just for this example, we're going to be looking at this weights and biases article about how to run LLMs locally with Llama CPP and GGML. This is, the reason we're using this article is because local LLMs and open source, more specifically open source LLMs, are a phenomenon that has only very recently come out. And so what we expect with no retrieval augmented generation, when asking a local LLM like Llama 2 or Mistral about local LLMs, we would expect, either hallucinations or, I don't know how to answer that, right? And that's why we do retrieval augmented generation, because we're trying to feed the model information that that may have not existed when it was training, or that it just was not aware of when it was training. And so we want to kind of ground it with new facts. So this is basically just going to the website and loading in the data in a raw format. And then what we do is we actually go in and chunk the data. So we chunk it into 500 character pieces. And then once we have it all chunked, we're going to be running our, Once we have everything chunked, we're actually going to be embedding all of our chunks. And so these embeddings are equivalent to the vectors I was talking about earlier. Essentially what we're doing is we're going to take all of these chunks that we've now created from this website that we just visited, and we're going to create a list of numbers that's going to represent in some form the meaning of each chunk. And then once we run that through the embedding model, what we do is we need to find somewhere to store all of these kind of sub lists of numbers. And that's where SingleStore comes in. So I love that Matt mentioned that SingleStore Pro Max is coming out really soon, because one of the features that really caught my eye was the 1000x faster vector search. This is something, and this is a use case where that would actually really come in handy. And so to sign up for SingleStore, you're going to want to go to singlestore.com/cloud trial. Some of you that already did the AirPods raffle giveaway might have already hit this page. Once the free share tier comes out, it won't just be a cloud trial. it'll be, just a fully free tier that you can use indefinitely. But once you've created an account and you're logged in, I'm just going to go ahead and log in here. You'll see a page kind of like this. And what you'll want to do is you'll want to create your first workspace. So let's see. So you're going to create a workspace and the page is going to look something like this. Since I have a number of workspaces in my list of workspaces, I had to click this little plus button next to the list of workspaces. But you should see a create a workspace button. But anyways, once you get that, you'll be able to kind of customize how much compute you'd like in your workspace, how much compute you'd like, how much RAM you'd like, whether or not you want to auto suspend it. But anyway, once you've selected all those details, you're going to create the workspace. And once you've created the workspace, you're going to want to attach a database to it. So once you click the workspace, you can select the option to attach like a demo database or something, but you're going to want your own database to kind of work with this LLM data, this vector data. And so you're going to create a database. Make sure to note down the database name. And then once you have the database created, I already have a database created here for this demo. You're going to want to go to this connect drop down here, and then click your app. And then so the first time you open this kind of pop-up, you'll see the password to your workspace. That's very important to note down and write down, because all other times that you open this, you will not see that. If you want to reset it, you'll have to reset it in another tab. But once you have that password and you have, you can select really any of these because you're just looking for a few details. You're looking for the password, you're looking for the username, the host, where it's hosted, and then the port. Once you have all of those details, you're going to go in, we'll just reconnect here. You're going to go in to your notebook, and then this is the format that you're going to type your URL in. It's going to go admin, and then so your username. So in most people's cases, that'll be admin, the username, colon, the password, at the host, colon again, port 3306, but I'll just write port here, and then backslash, and then the database name. So that's the name that you selected when you attach the new database. It's important to keep this format in mind. Otherwise, you might run into some authentication errors and whatnot. But anyway, once you have all of this typed in, you're all set to use SingleStore entirely within code. You don't have to, you can go forget about the portal now. And the way we're going to do that is by using this from documents function, which will take our split up documents, those chunks. It'll also take the embedding model that we're using, and we're using in this case a local embedding model from Hugging Face. We're using Hugging Face embeddings, and then what we're doing is we're just going to Hugging Face, searching for a sentence transformer model. In this case, we're using all MPNet base v2. This is a relatively lightweight model that kind of works across a variety of domains to kind of map vectors in semantic space, vectors with a certain meaning associated with them, to a wide variety of chunks of text. And just quick pause note here. I know I'm getting into a lot of technical terms, so please do feel free to use that Q&A function. We will have time for Q&A at the very end. Okay, and then so once you have all of these pieces set together, you're all set to perform retrieval augmented generation with Mistral or the Llama 2 model, using a local embedding model on SingleStore database. The last detail that I forgot to mention is that you can actually use SingleStore completely locally as well. We do have a solution called SingleStore Self-Managed, which allows you to host your own SingleStore instance entirely locally. So if you would like, you can basically have an air-gapped LLM inference and vector storage box with all of these pieces that we talked about here, right? So once you do have all these pieces, you can use, a LangChain QA chain to kind of automate a lot of these pieces. A QA chain will basically, what it'll do is use the embedding model on your query, and then find chunks of text that are related to that query in your vector database, so in this case, SingleStore. Finally, take all those chunks of text, the most relevant chunks of text, prepend them onto the prompt, which is, given these chunks of text and this question, can you formulate a helpful answer? And then the LLM, which in this case is, Mistral or Llama 2, will do its best to answer the questions in the best that it can. So that's, a lot that we just went over. I'm going to take a look at the questions now. We will have some time for questions. Let's see.
Awesome. Alex, you ready to start the Q&A?
Yeah. Matt, do you mind dropping the link to the code in the chat?
Yes, I will. I'll put that in. I put it in earlier actually as you started, but I'm gonna put it. I know some people come and go and they lose access to the chat. So here's that GitHub link. And reminder to everyone, we've already got some questions come in that we can start through, but you're welcome to participate throughout. We'll try to get to as many of the questions as we can. So, Alex, one question that came in while you were talking was about whether you are downloading the entire model locally.
Yes. So the short answer to that is yes. And that's really the whole reason that we wanted to kind of put this demo together, right? Lots of people have data that they would like to keep completely private, for compliance reasons, for privacy reasons. And so this method of running open source LLMs on your own hardware, it does require that you download basically the entire model locally. But once you download that entire model, and it's something like, I don't know, 4 gigabytes, 5 gigabytes, you are free and clear to use it on whatever data you'd like. You can turn off your internet. It's not going to talk to anyone. And so the answer to the question is yes, for a variety of reasons.
Good stuff. Two-part question that came in from George. First, he says, great session. So kudos, Alex. And then he says, well, first question, how do you have your model output the sources that it used to ground its answer, like citations, I guess?
Yeah, great question, actually. So I would actually go and look at the LangChain documentation for this specifically. I know the capability exists to have the model cite sources, so basically output the chunks that it found most relevant to your query alongside the answer. But I don't know the exact argument that you put in, but it's just probably an argument or switch that you flip.
Good stuff. Another from George. Do any of these models have moderation or toxicity evaluation? Do you need external frameworks to achieve this? And I know this kind of reminds me of, we've done that past webinar on Uptrain, which is like, studying the responses that you get from your LLM to make sure it's not doing hallucinations and to kind of like optimize that. And it also reminds me of what Akmal said on Friday during his stock ticker webinar, where he was like, I always set the temperature to 0. I do not want it inventing, answers. I want it all based on the data that I'm giving it. But yeah, Alex, I'm curious if you have any thoughts on that.
Yeah. So to answer the first part of that question, does this model have, or do these models have any sort of moderation or toxicity kind of limitations on them? I believe for these specific models, they do not. Llama 2, well, actually, no, I'm going to revise my answer. Llama 2 does, it was released by Facebook. They're very keen on making sure the model doesn't output anything super toxic. Mistral, I believe, is a specifically non-moderated model, though what you can do, and this is what all the companies that have been training their own models have been doing, is reinforcement learning from human feedback. So if you're finding that you're using this model in a consumer facing setting and it is generating toxic outputs you do not like, then what you do is collect examples of those toxic outputs and you basically assign negative scores to them and you fine tune your model to kind of have your own customized version of it that hopefully is less toxic. On that temperature piece, that's actually it's interesting that you brought that up. So for those that don't know, temperature is an argument. It was actually in the Llama CPP initial class initialization. Temperature is an argument that you use when running LLMs to, it's a very rough and crude kind of knob for controlling how creative you would like the model to be. So if anyone's used like Bing Chat, you choose between like more precise, balanced, creative, you're basically changing the model's temperature. But I think it's misleading. And it's for this reason. You can set the model to temperature 0, and if you retrieve documents that are out of date or misleading or just unrelated, you're still going to get a hallucinated answer. You'll just have this false sense of security that it's not, or less likely to be hallucinated because you set the temperature to 0. So I think the better way to go about this is to set up a retrieval benchmark over your own data and have that be a test, right, for whenever you make a change to LLM. So when you have this certain query, like let's say your Google, right, and you're building an internal company tool and you set up your retrieval benchmark to be, when I search for Google AdWords, I should return as the most relevant chunks of information like this documentation on AdWords, right? It should not spit out some nonsense about other things within Google. But anyway, yeah, that's way off on a side tangent. Good question though.
Good stuff. Here's another one from an anonymous attendee. If you have made a RAG model that should answer questions related to PDFs, would you recommend using a new database for each PDF file, or would it be able to differentiate between your PDFs if they are chunked into the same database on SingleStore?
Yeah, great question. I would say keep it all in one database. And that's mainly because, if your embedding model is not good enough to be able to differentiate between, different chunks of text across, a kind of mixed database of many different, chunks of text from many different PDFs, you should probably change your embedding model. The embedding model that we use in the demo is actually a pretty small and lightweight embedding model. It's probably not going to be the best for every single use case. I used it because it runs on consumer grade hardware and kind of has decent performance across a variety of tasks. This is something that I brought up in past webinars too, but fine-tuning embeddings is definitely an option to look into. And one way you can do this is there's another LLM framework called Llama Index, which we also have a first class integration with. And they have a really cool library called Fine-Tune Embeddings, where it kind of just walks you through how to create examples to fine-tune an embedding model so that you get better retrieval performance on your own specific data.
Good stuff. I see one question from Cisco Ramirez. It's about, could you give us any metrics on Mistral versus Llama 2? I'm thinking of I know how Bard recently released their stats on GPT-4 versus Pro and versus the upcoming Ultra. I haven't seen anything formal. Have you seen anything?
Yeah, I mean, I was just looking at this earlier, debating whether or not to stick it in the slides, but I figured it might be too into the weeds for people to be interested in like the specific performance on different benchmarks. But since you asked, let me pull this up. I'll share my screen too.
Okay.
Let's see. So Mistral, the Mistral mixture of experts model, which is their kind of best model out so far, has these kind of performances on the different benchmarks that people tend to benchmark LLMs on. I would take these with a grain of salt. Personally, I find Mistral to be the best open source LLM, generally available today. But the very important thing is to always test on your own use cases and to have kind of, even if it's just like 4 or 5 tests that you write, to have a kind of personal benchmark for your data, for your use cases, for the responses that you expect to receive, because these open source LLMs can obviously vary a lot in their performance in different domains, right? These benchmarks try to capture a snapshot of that, but I think they're imperfect. It's very possible GPT 3.5, even though it's beat kind of more generally by Mistral, it performs better on your personal use case. So I would say you'd have to look at your own uses.
That makes sense. What about, there's been a question, and this is a popular question. Is it possible to combine different LLMs for inference? And it also reminds me of a follow-up question, which is, would you want to? Like I remember Akmal months and months ago, he would say like OpenAI is not good at math. It's really good at text semantics. It's not good at math. But since then, they've released so many updates, and BART is the same way. Do you see a value in using different LLMs for different situations, or would you just say just pick the best that's kind of good at across the board? What do you think?
Yeah, so actually very interesting question to have brought up. This paper just very recently came out. And I saw it the other day and thought this might be interesting for whoever asked this question to check out. They basically found that by randomly selecting sometimes even the LLMs used at each inference point. So like, you'd be having a chat session, right? And then you'd first chat with ChatGPT, then you'd chat with Llama, then you'd chat with Mistral, right? You actually end up getting a better performance than any single LLM. And the reason behind this is more vague. Some people think it has to do with the fact that like the LLMs kind of refresh themselves each time, like they're working off of a each time an LLM performs inference, they're working on what they see to be like an entirely fresh set of data instead of just appending onto an ongoing conversation. And that seems to help with performance. But anyway, I would check out this paper. They've actually investigated specifically this question.
Can you put that link in the chat, and I'll share it with the
Oh,
group?
sure. Yeah, here it is.
Another question here. This one's from Sebastian. It's about chunk size. Can you get more precise or accurate with different size chunks? And this kind of reminds me both what you were just talking about and that example you've used in the past of like, if a professor gives you a fact and then asks the quiz question, they're going to get it every time. But if you give 2 hours of rambling, they're not, the students aren't going to be as good at answering those questions. And that kind of feels relevant to what you just described with like a fresh slate for each of these LLMs. You're asking the different LLMs, the same question. I don't know. I guess, do you have any thoughts about chunk sizes or how to get, more accurate answers?
Yeah, so the tedious answer to this is you're going to need your own benchmark and try out different chunk sizes and see what works best for your own use case. That being said, the kind of more general kind of experience that I've had with chunk sizing is smaller chunk sizes tend to work better. You want to generally see, if you can get away with as small a chunk size as possible. Obviously, if you have a chunk of like one character, you're not going to be able to get any meaning out of that. And the reason for that is The chunks get passed through an embedding model, right? An embedding model basically looks at each chunk. So, say a sentence, 10 words, and it tries to assign a vector to it that tries to encode the meaning of that sentence against the meaning of all other possible sentences, which is a pretty hard task. So you want to give it, a meaningful unit of information, like a self contained idea. But obviously, it'd be very hard to go through, 900 pages of PDFs and try to like delineate every single self-contained unit of information in each sentence, right? And so there's a number of different strategies you can try. Like in the demo, we use the recursive text splitter, which splits at new lines and then recursively goes back into split chunks and then also splits again at new lines. You can try there's a number of different chunking like there's new chunking strategies now, like big to small, where you chunk really big, or small to big, sorry. You chunk really small, so you chunk only like a sentence or a few words at a time, but you associate with that chunk like the larger paragraph around it, so that when you perform inference, you end up having a lot more context,
Context.
right? And hopefully that context is more relevant because you chunked small, and so the meaning of the words will match up better when you embed your query again and try to see what's going to answer that query. But yeah, happy to answer more about that.
Interesting. So see, I love these sessions because our audience can teach us new things too. I see this from Jeff. Microsoft Auto Gen allows me to use many LLMs together. Shared a link. I'm going to put that in the, I don't know, have you heard of Auto Gen? I've never heard of that, but I want to read about it now.
Yeah, I have actually. I think that's the one where you can have like multiple LLMs like talking to each other. So that might have been what the blending is all you need paper kind of used for their implementation, but I can't be sure. I haven't read the paper myself, just the abstract.
Here's one of the latest, but it's what's the hardware requirement for hosting a private 100% on-premise RAG model?
Um, it depends. You you know you have your general. So the most important spec that you're going to be looking at is GPU RAM. That's a really expensive spec. Like, each additional gigabyte is probably hundreds of additional dollars, if not thousands, as you kind of get into the higher gigabyte ranges. Um, it's going to depend on your task, right? So if you have a relatively simple task, like, automatically captioning or categorizing, a bunch of incoming emails in your personal mailbox, um, then you can just probably run it on your personal laptop with like, a really small model, which has the right amount of reasoning and factuality capability for your task, right? Um, it's the reason that you don't use, like a giant hammer for like, a tiny little nail on like a toy model project, right? Like, on the other hand, if I know someone else just asked about medbert and healthcare applications, that's a case where you're really concerned about factuality and reasoning. And so you might have in the basement of your hospital, you may have like a pretty big box of like 8 GPUs in line. And then you're going to be running like the 70 billion parameter Llama 2 model fine-tuned for your specific use cases. And then to just answer that question about using medbert, you definitely can. For all of these kind of different models, with this demo, you can pretty much plug and play. It's obviously, pretty toy example, and you're going to want more testing, you're going to want better benchmarking, you're going to want probably more rigorous code than a 1 hour webinar is going to give you. But this gives you a pretty good start.
Good stuff. Yeah, it kind of reminds me of the stuff we did on Google Gemini and Pro and their small model. Is it called the Nano or something that can run locally on the Google phone? And it seems like way less impressive than like Ultra or Pro, but it seems like the Nano still can do some. I can't remember what it was doing, like conversation summaries and email, much better pre-populated messages. So it'll just be kind of interesting to see how that manifests over time. I haven't played. I have an iPhone. I haven't played with the Google Nano or anything like that, but that'll be cool to see.
Oh, I just wanted to point out one more question in the Q&A that caught my
Go
eye.
ahead.
So Christopher Stokes asked, in the retrieval QA from chain type method, we pass in Mistral LLM as an argument, but earlier in generated embeddings with the sentence transformer model. Do we not have to be careful that embeddings for prompts are generated by the same model we use for vector storage? Otherwise, the vector space might not align correctly between the two, leading to some potentially inaccurate retrievals. Really good question. So I'll tackle this question in kind of two parts. First, do we have to be careful that embeddings for prompts are generated by the same model we use for vector storage? That's almost there, not quite. We do have to be careful that the embeddings for prompts are generated by the same model we use for vector storage. And that's guaranteed by the fact that we pass in embeddings as an argument to the vector store constructor. When we define the Hugging Face embeddings in the code, I'll go ahead and pull it up here, just so everyone knows what I'm talking about. Let's see. Llama 2 versus. Oh, yeah. Here we go. So we do end up passing in that embedding model as an argument here. And so when we use this vector store as a retriever, we will use the sentence transformer embedding model for prompts and for vectorizing our chunks when we initialize the vector store. We do still use the LLM at inference time for generation, but that's after we've collected all the retrieved chunks with the embedding model. The other part of that question was, I believe, might the vector space not align correctly between the two, leading to potentially inaccurate retrievals? That actually is a concern, and that's if you use a different model for vector instantiation versus vector retrieval. So, for example, if you populated a SingleStore database with one embedding model with a bunch of checks, with a bunch of chunks, embedded chunks of some text that you're interested in, and then you go back at retrieval time and use another embedding model to embed your prompt, yeah, you're going to get weird results. So the upshot of that is anytime you decide to change your embedding model, so say you fine-tuned a new embedding model with examples using the Llama index embedding model fine-tuning library, anytime you change that, you're going to want to re-embed your document corpus. So that gives you some pause. If you have 1,000 pages of PDFs and you fine-tune the embedding model and you're finding on your benchmark you only improved like 2%, is it worth re-embedding your entire body of documents? Maybe not. If you improve like 50%, maybe it is. So that is the
Good point.
long answer to that.
It's a good point. We should probably wrap up and announce the AirPods winner for today, but I want to give you a quick chance, Alex. Do you see? I know there's a lot of questions we're going to need to follow up with via email just based on time. But do you see any? Have you seen any questions in there that you really wanted to answer before we wrap up?
No, I think we're all good.
Sounds good. Okay, so I just put this in the chat. A reminder on Monday, we're doing real-time AI with Kafka and streaming data analytics. We're going to do an awesome demo then on LangChain and OpenAI with an ad tech application, being able to ask real-time questions about which campaigns are performing best and other factors in advertising. And then on the 24th, we're going to be presenting our Meet SingleStore Pro Max. These are all the new features that our engineers have been working on that really empower the next generation of real-time AI features for your applications. So if any of that sounds interesting to you, RSVP right now. I put those links into the chat. I hope to see you there. The announcement you've been waiting for. Today's AirPods winner goes to VJ Raghavan, Senior Director of Applied Science at Thumbtack in San Francisco. Congrats, VJ. Thanks for joining. If that's not you, don't give up. We're going to give out one more AirPods by the end of the day to anyone who tries Alex's GitHub. You've got it in the chat. I'll put it in there one more time. And we're also going to include it in the email. Everyone is going to get a copy of the recording of this session, a link to this GitHub that I just put into the chat. You can pull it up now if you want. And yeah, you should be good to go. Stay tuned. Hopefully you'll be the next AirPods winner if you give this a try. And thank you to Alex for another awesome session. Thank you to our audience for joining us, and have a great rest of your day, everyone.
Thanks, everyone.
Bye-bye.